first of two videos about the inverse of a function. I should probably apologize now that I have the hiccups, and I probably will throughout this video. So laugh along at home. Um, I want to talk about the inverse of a function, but before I can do that, I feel like I really need to talk about what a function is. And I know you guys have heard that from me before, but in case you've forgotten, that's what I'm going to talk about first. So a function is effectively a relation for which each input has at most one output. In other words, a single input value can't have multiple different output values. So some examples are the following things relations or functions? I'm sorry, are the following relations functions? So one of the easy ways to do this is for me to make a little chart of x versus f of x. It's a little bit surprising to me that this was green. I was expecting this to be a black pen. So let's say I've got something like 1, 2, 3, 4, 5, and then I've got 2, 3, 4, 3, 2. I could ask the question, is this thing a function? And again, the thing that's important about a function is that, when you plug in 1, you get back 2. When you plug in 2, you get back 3. When you plug in 3, you get back 4. Plugging in 4 gets you 3, and plugging in 5 gets you 2. And so the question is simply, does each input value have at most one different output? And the answer here is yes, right? So is this a function? Yes. Right? And again, the reason is when I plug in 1, I get back one thing, it's 2. When I plug in 2, I get back one thing, it's 3. When I plug in 4, I get back one thing, it's 3. Okay? Let's look at another example. What if this time I did x versus g of x, and this time I did 1, 2, 3, 4, 1, 2, and got back 5, 3, 5, 3, 3, 5. Same question, is this thing a function? Right? Well, in this case, we can tell that the answer is no. And the reason it's no is what happens here when you plug in 1. Well, when I plug in 1, I get back 5. Or possibly when I plug in 1, I get back 3. The reality here is that when I plug in 1, there are two different outputs. Two different outputs for x equals 1. For an input of 1, there were two different outputs, and that's bad. So in this case, the answer is no, that it's not a function. What you guys have all seen before is you've seen the vertical line test. So a much more common way of asking this question is they'll say, okay, well, what about for this one? What about this thing? Is this a function? And the answer is, of course, yes. And the reason that everybody's comfortable with is, oh, look, it passes the vertical line test. Yay! But I'd like you to think about what that actually means. What it means is, what happens when you plug in this x value? Well, you get back that y value. What happens when you plug in this x value? Well, you'll get back that y value. What happens when you plug in, let's see here, this x value? Well, that gives me this point, which is that y value. Notice that anywhere that I go, because it passes the vertical line test, each x input will only have one y output, right? So in the same vein, let's look at something that's not a function, right? Let's look at something that fails the vertical line test. What about something like this, right? For some values, we're fine. When I plug in this x value, how many y values do I get back? Well, if you follow this down to the function, you'll get that point, which means that is the one red y value that comes from that red x value, right? Similarly, what happens when I plug in this green x value? Well, point for that is right up here, and so that's the y value that I'm going to get when I plug in that x value. Where it gets messed up are the places where it fails the vertical line test. Like, for instance, here. What happens when I plug in that x value? Well, the reality is I'm going to get back that point, which means that y value, or maybe that point, which means that y value, or maybe down here, this point, which would mean that y value. Notice that for this x value, there were 3 different y value outputs that I got. And that means that that thing is not a function. So this is sort of my explanation for why the vertical line test works. Remember that the vertical line test is used to determine when something is a function. So again, just making sure, the vertical line test is the thing that you use to determine whether something's a function. For the things that I have here, the top one passes the vertical line test, and so yes, it is a function. The bottom thing, it does not pass the vertical line test, so no, this bottom one is not a function. Okay? So now that I've said all of that about functions, we can kind of go back and talk now about inverses, right? So what is the inverse of a function? And that's really what I want to talk about next. So the inverse of a function is really just where I take a given function. So let's say we take a function like this, x and f of x. And let's say we've got, kind of a boring function like 1, 2, 3, 4, 5. And the function gives me these outputs of 3, 2, 5, 1, 6. Right? So the question is, what is the inverse function? And all the inverse function does is it applies the same function backward. In this table that I have here, all these top things are basically inputs. And I'm sorry, all these bottom values are outputs. I have to imagine that's rather hilarious at home. That are really distracting, sorry. So the top numbers are inputs, the bottom numbers are outputs. So what if I wanted to make a table for the inverse of this function, right? Well, the inverse of this function would simply say that 3 goes to 1, that 2 goes to 2, that 5 goes to 3. Notice all I'm doing is I'm taking 1, 3 and making it 3, 1. Taking 2, 2, making it 2, 2. Taking 3, 5, making it 5, 3. I'm just flipping all of these things around. 1, 4, and 6, 5, right? And so the question I would ask here is, well, actually, do I even have a question here? Yeah, I might as well. So this original thing, this thing up here, was this a function? The answer is yes, because each input is only being used once. So this is a function. Right? So and specifically, we could say that f of x is a function. Potentially the more interesting question is, what about the inverse? Is the inverse a function? And you'll notice here, it sure is. 3 goes to 1, 2 goes to 2, 5. Up here on the top, there are no x values that are used more than once. So the inverse is a function. Right? So part of the question now is, so if I have a function, is its inverse always a function? And the answer is no. The inverse of a function is not always a function. In fact, there's a fancy term for that, and I'm going to scroll the slide up and give you that term now. It turns out that if the inverse of a function is also a function, that function is called one-to-one. Let me write that out, and we'll talk about it more. Here we go. A function is called one-to-one if its inverse is also a function. And so in other words, if a function is one-to-one, then not only is it a function, but its inverse is also a function. So what I want to do now is I want to give you an example of a function that is not one-to-one, right? So this function will not be one-to-one. Right? And so let's see if we can generate a function like that. I need it to be a function. So 1, 2, 3, 4, 5, 6. It's actually an interesting point. Notice right now, it almost doesn't matter what I write down on the bottom. This will be a function. And the reason is I only used 1, 2, 3, 4, 5, 6 once, which means each of them can only have one output in these spots down here, right? But one way that I can make this thing not one-to-one is by doing this. By saying, okay, my outputs here will be 10, 11, 12, 13, 14. Now, so far, it's one-to-one, and I want you to notice that. It's one-to-one because when you plug in the inverse, if you plug 10 into the inverse, you'll get back 1. If you plug in 11 to the inverse, you'll get 2. If you plug in 12 to the inverse, you'll get 3, right? So what do I need to do with this last spot for the inverse of this thing to not be a function? Well, all I have to do is use one of those things again. So for instance, I could go 10 again. Because now this begs the question, what happens when I plug 10 into the inverse? When I plug 10 into the inverse, I'll get back 1 or maybe 6. And that's not good news. If you're trying to be a function, then that's not good news, right? I'm going to throw one more thing into this video, and then I'll be done with it. So hopefully it's clear to you when a function is one-to-one if you have a table. The last question I want to answer is, how do you tell if a function is one-to-one based on a graph? And that's what I'm going to scroll up, and that's the last thing we'll look at here. So we can tell if a function's one-to-one from its graph if it passes both the vertical and horizontal line tests. Of course, the vertical line test just tells us that the function is actually a function, and the horizontal line test will tell us that after you take the inverse, it'll still be a function, right? So for instance, let's see here. Is this thing a function, right? The answer is yes, because it definitely passes the vertical line test, right? So this thing is a function, but is it one-to-one? Is its inverse also a function? Well, if we look at a horizontal line test, right there, we hit 3 points, which means this thing is not one-to-one. So this is a function, but is not one-to-one, right? If we look at another example, one last example in this long video, sorry. What about this? Is this function one-to-one? Well, does it pass the vertical line test? Yeah, since every time I pass a vertical line over it only hits once, it is a function, right? Does it also pass the horizontal line test? It absolutely does. Because it passes the horizontal line test, we also know that its inverse will be a function, right? So we could say this function is one-to-one. So I know this video was pretty theoretical. The next video is going to be very, very practical in terms of us figuring out what the inverse of a function is and what other things we can do with it. So I will see you in that video.